PMC loudspeakers are known for their 24 dB fourth-order crossovers. But what does this mean? And why has PMC chosen to design its crossovers in this way? And indeed, what is a crossover? The ideal loudspeaker would use one drive unit which can handle all frequencies, from the lowest to the highest. But this unit doesn't exist, and consequently, the designer must resort to separate drive units for low frequencies and high frequencies. And this requires the development of an electrical circuit called a crossover. The drive units used in a loudspeaker are chosen for their ability to perform well at certain frequencies. For example, a 5.5-inch unit works particularly well for the bass and mid-range frequencies, while a tweeter works at high frequencies. Outside of these frequency ranges, the drive units do not perform well, with distortions and unwanted harmonics becoming evident, or in the case of the tweeters, mechanical damage can occur when powerful low frequencies are fed to the delicate unit. The role of the crossover is to send the correct frequencies to the correct drive units. Its name very accurately describes its function, to cross over from one unit to another. To do this seamlessly is the key to good crossover design. Simply described, a crossover is an electrical circuit that splits the music signal from an amplifier into separate frequency ranges that are suitable for each of the drive units used in the loudspeaker. With PMC's designs, that might be 2 units or 3 units. The number of drive units selected by the designer determines the type of crossover required, 2-way or 3-way. The simplest form of crossover is called first order, and in a 2-way design uses an inductor or a coil of wire attached to the bass driver, which allows only low frequencies to reach this driver. Another component, a capacitor, is attached to the tweeter, and this enables only the high frequencies to pass through to this unit. A first order crossover has a shallow roll-off of 6 dB per octave. Where the roll-off of the 2 drive units meet, the frequencies sum and produce an overall flat response, which is what the speaker designer is looking for. Theoretically, a first-order crossover should be the best option for good quality audio and low cost, as it has the minimum number of components. However, in reality, a first-order crossover rarely gives an acceptable audible result, as drive units introduce distortions above and below their optimum operating frequencies. Because the roll-off is very shallow, it's easy to hear the bass driver working above the crossover point and the tweeter below the crossover point, introducing unnatural coloration and unwanted distortion. It's for this reason that PMC chooses to use fourth-order crossovers. Second-order and third-order each introduce a steeper roll-off of frequencies, and each is progressively more natural sounding. But a fourth-order design, in which the roll-off is a very steep 24 dB per octave, effectively silences the drive units above and below the crossover point. The very steep slope ensures the drive unit is not adding any distortion to the musical signal. The prevention of any unwanted lower frequencies getting to the high-frequency driver also provides greater power handling and reliability. Fourth-order crossovers also control the total dispersion characteristics of the loudspeaker, providing an optimum wide and smooth off-axis response over a vast listening area. Precision fourth-order crossovers are challenging to design due to the high number of components required in the circuit and the potential for unwanted electromagnetic interaction between those components. For this reason, most speaker manufacturers opt for simplistic designs. But PMC is uncompromising in its approach and puts enormous effort and expertise into designing the best fourth-order crossovers. This gives PMC loudspeakers a significant performance advantage compared to others, and is the reason they are chosen by producers, engineers, artists, and music fans across the world.